Hi, thank you for signing up for one of the GETSI Geodesy Tools for Societal Issues mini short courses. You only need to watch this introductory video about GETSI and Geodesy the first time you take a mini course with us. And then after that, we'll figure that you have it. I'm Beth Pratt-Sitola, and I am the project manager for the project. A little background on why we have the societal issues part of our title. It's really a guiding philosophy for how the materials were built. And the idea behind that is that we have many challenges in the geosciences, from storms and flooding, climate change, water resources, natural hazards. And we also have this challenge of increasing student engagement in STEM and science, technology, engineering, and math. But it turns out that there really is a complementary path to improvement for both of these, because if we situate the science, the STEM learning in the context of how we can address societal challenges, students are more engaged, they learn better, and they may even be more likely to consider a STEM career. The GETSI project mission is to develop and disseminate teaching and learning materials that feature geodesy data and quantitative skills to critical societal issues such as climate change and water resources and natural hazards, things that geodesy can help with. It is a sister project to the Integrate project run by the Science and Education Resource Center, SERC, and partners. The U.S. National Science Foundation has funded GETSI through 4 grants. In total, there have been 13 modules developed of about 2 weeks each, introductory and majors level, classroom, and field. To make sure I'm on the same page, geodesy is the science of accurately measuring the Earth's size, shape, orientation, where the mass is, and how these things change with time. Traditionally, it was precise positioning of points on the surface of the Earth because it was hard enough just to do basic surveying. But in the last few decades, the toolbox of methods that are available for measuring the Earth has just burgeoned. So if we unpack that toolbox a bit, we find GPS, Global Positioning System, so valuable for things like plate tectonics and earthquakes, increasingly used for things in the hydrosphere, with the vertical signal helping with ice and water. There's INSAR, Interferometric Synthetic Aperture Radar, which is mostly satellite based and can give regional deformation, in this case showing an earthquake deformation, but also volcanoes or fluid subsidence from fluid withdrawal. Anything that's high resolution topography, be it from laser scanning or structure from motion photogrammetry, is considered to be geodetic. Strain meters, tilt meters, creep meters, often used near volcanoes and earthquake faults. And gravity measurements, especially from the GRACE gravity satellites that have given us so many insights into changing ice and groundwater. And finally, ice, sea level, and ice altimetry, often satellite-based, but it can be also from airplanes. So all of the modules in GETSI, and also a parallel with the Integrate project, have 5 guiding principles, which is addressing one or more geodesy-related grand challenge facing society, make use of credible and authentic geodesy data, and in many cases other kinds of data as well, improve student understanding of the nature and methods of geoscience, how science is done and how it's communicated, develop student ability to address interdisciplinary problems and apply geoscience learning to social issues. This is really where the societal issues part comes in. And this is not just things like, oh, earthquakes can knock down buildings, but like, let's understand our geology better so we can tell where the biggest hazards are, and then delve into something in economics or policy that can help us make better decisions. And finally, to increase student capacity to apply quantitative skills in geoscience learning at whatever level is appropriate for the level of the module. So the module development and assessment follows the model developed by the Integrate project. It uses backwards design, which starts by saying, well, what do we want the students to be able to know and do by the end? What are the learning goals? And then consider the more sort of unit level learning outcomes, a little more granular. And then the next step is to say, well, like, how would I know if that's been accomplished? What's the assessment strategy that would help us know that the goals and outcomes have been achieved? And then you move on to things like designing the teaching materials and the instructional plans. All GETS-E modules were then pilot tested by both of the authors and a third non-author tester, revised, and then published. So anyhow, we look forward to seeing you very soon in the mini short course that you have signed up for. Thank you.